For nearly half a century, one small spacecraft has continued a journey no human has ever witnessed firsthand. Far beyond the planets, beyond the icy edge of the solar system, Voyager 1 travels through a region where sunlight is little more than a distant glow. It was never designed to survive this long. When NASA launched Voyager 1 in September 1977, engineers expected it to complete a relatively short mission. Its primary objective was straightforward: visit Jupiter and Saturn, gather scientific data, and transmit its discoveries back to Earth before gradually falling silent. Instead, the mission became one of humanity's greatest achievements in space exploration. Built with 1970s technology, Voyager 1 carried computers with only a fraction of the processing power found in today's everyday electronics. Every command had to be carefully planned because once the spacecraft left Earth, repairs would be impossible. Yet despite these limitations, Voyager exceeded every expectation. Its first major destination was Jupiter. Until Voyager arrived, scientists knew Jupiter was a giant planet wrapped in colorful clouds, but many details remained hidden. As the spacecraft approached, it revealed an astonishingly dynamic world. Powerful storms stretched across the atmosphere, including the enormous Great Red Spot, a storm so large that Earth could fit comfortably inside it. The images showed swirling cloud bands moving at tremendous speeds, demonstrating that Jupiter's atmosphere was far more active than anyone had imagined. But perhaps the greatest surprise came from one of Jupiter's moons. Io appeared, at first, to be an ordinary rocky satellite. Then Voyager captured something completely unexpected. Towering plumes of volcanic material were erupting high above the surface. It was the first direct evidence of active volcanism beyond Earth. Scientists realized that Io was constantly reshaped by powerful gravitational forces generated by Jupiter and its neighboring moons. Instead of being a frozen, lifeless world, it was one of the most geologically active places in the solar system. Voyager also measured Jupiter's enormous magnetic field. This invisible shield extends millions of kilometers into space, trapping energetic particles that create one of the harshest radiation environments known around any planet. These discoveries transformed our understanding of giant planets and their surrounding environments. After completing its investigation of Jupiter, Voyager continued toward Saturn. For centuries, Saturn's rings had fascinated astronomers. Viewed from Earth, they appeared smooth and continuous. Voyager revealed an entirely different picture. The rings were made of countless individual particles ranging from tiny grains of ice to larger fragments orbiting together in intricate patterns. Scientists observed delicate waves, narrow gaps, and complex structures shaped by gravity, creating one of the most beautiful natural systems ever photographed. Saturn's moons also became objects of intense scientific interest. Among them was Enceladus, an icy world that seemed quiet and frozen. Although Voyager could not directly observe everything hidden beneath its surface, its measurements hinted that this small moon might possess a far more complicated interior than previously believed. Years later, follow-up missions would confirm that Enceladus contains a global ocean beneath its icy shell, with enormous plumes of water vapor erupting into space. Those discoveries helped establish Enceladus as one of the most promising places in the solar system to search for conditions that could support life. By the time Voyager 1 completed its exploration of Jupiter and Saturn, the mission had already rewritten astronomy textbooks. What began as a planetary flyby had become one of the most successful scientific expeditions in history. But remarkably, its greatest journey was only beginning. Leaving the giant planets behind, Voyager continued moving farther from the Sun, heading toward a region no human-made spacecraft had ever reached. Ahead lay the mysterious boundary between our solar system and interstellar space, a frontier that had never before been crossed. After completing its historic encounters with Jupiter and Saturn, Voyager 1 left the familiar planets behind and entered a region no spacecraft had ever explored. Ahead lay the outer frontier of the Sun's influence. For decades, Voyager continued moving farther into deep space, powered only by its momentum and a small radioisotope generator that slowly converted the heat from decaying plutonium into electricity. As the years passed, Earth became unimaginably distant. Radio signals traveling at the speed of light required more than 22 hours to reach the spacecraft, and another 22 hours for Voyager's reply to return. Every command became a conversation spread across nearly 2 days. Yet the spacecraft continued operating. Then, in 2012, Voyager reached one of the most important milestones in the history of space exploration. Its instruments recorded dramatic changes in the surrounding environment. The number of charged particles flowing outward from the Sun dropped sharply. At the same time, high-energy cosmic rays arriving from the Milky Way became much more common. These measurements indicated that Voyager had crossed the Heliopause, the outer boundary where the Sun's solar wind gives way to the interstellar medium. For the first time, a human-made object had entered the space between the stars. Although there was no visible border, the data clearly showed that Voyager was now traveling through a completely different environment. Scientists soon made another remarkable discovery. Interstellar space was not empty. Voyager detected subtle vibrations moving through an incredibly thin gas that fills the galaxy. These waves, traveling through interstellar plasma, revealed that even the enormous distances between stars contain matter, magnetic fields, and energy. The region beyond our solar system is not a perfect vacuum. Instead, it is part of a vast and interconnected galactic environment. Some of these plasma waves are believed to have been triggered by distant stellar explosions, sending disturbances across light years of space before eventually passing Voyager. Each measurement provided new insight into a region that had never been explored directly. Today, Voyager 1 continues this historic mission under increasingly difficult conditions. Its electrical power decreases slightly each year, forcing mission engineers to make difficult decisions. To conserve energy, instruments have gradually been switched off one by one, allowing the remaining scientific equipment to continue operating for as long as possible. Despite its age, Voyager continues sending valuable information back to Earth. Attached to its side is one of humanity's most symbolic creations, the Voyager Golden Record. This gold-plated record contains sounds, music, greetings in many languages, images of Earth, and recordings of everyday life. It was never intended as a likely means of communication. Instead, it serves as a time capsule, a message representing the curiosity and creativity of the civilization that built the spacecraft. Long after Voyager's instruments eventually fall silent, the spacecraft itself will continue its journey. It will orbit the center of the Milky Way for millions of years, quietly drifting through interstellar space as a lasting reminder of humanity's first attempt to reach beyond its home. Voyager 1 has already transformed our understanding of the solar system, revealed active volcanoes on distant moons, explored the giant planets in extraordinary detail, and become the first spacecraft to investigate the environment between the stars. Its mission proves that exploration does not always require the newest technology. Sometimes, determination, careful engineering, and scientific curiosity are enough to achieve the impossible. Even now, as Voyager grows older and fainter with every passing year, it continues doing exactly what it was built to do. Exploring the unknown. Sending home discoveries. And reminding us that the universe is far larger than we once imagined. Somewhere beyond the planets, beyond the Sun's protective bubble, humanity's most distant explorer continues its silent voyage, carrying with it the enduring story of our desire to understand the cosmos.